Okay, basically what I'm going to be doing today is explaining the constant multiple rule. It sounds pretty complicated, but it's actually finding the derivative, and it's kind of what we've been doing all along. So basically, f at x is just the function that we're finding the derivative for, but f at x is the function. So k just represents a constant, and f of x is basically f at x without this constant. So to start, we find the derivative like we would we use a derivative formula. So k is basically what we factor out of the derivative formula, and to find the definition of the function, which looks like this. And then what we do is we find the derivative of the function first using this formula, then we multiply k back into the derivative of the function and to get the derivative of the final function. Complicated? Does it seem complicated? Alright, cool. So an example of this is, okay, basically this represents f at x like it did in the theory. 7 represents the constant, which is represented by k, and then x cubed is just g at x because it's just the function without the constant, which is k. So the first thing we do is we find the derivative of the function. So the derivative of x cubed is actually just 3x squared. We use our shortcut to find that. And then what we do is we just take the k value and we multiply it back into the g at x, or we multiply it back into the derivative to get 21x squared. And that's our answer. So it's kind of what we've been doing all along. The only difference is we take the k or the constant out first, and then once we find the derivative of the function, we multiply it back in. Now, it might not seem that useful, but if you're using more than one, if you have more than one, if you have more than one function, it's pretty useful because it adds up. Then the second way to do this, another example of this, is 12x to the power of 4 over 3. This looks a little bit more complicated, but it's pretty much the same. We take the constant, which is 12, out, and we find the derivative of x to the power of 4 over 3. We use our shortcut to find this, and we get 4 over 3 x to the power of 4 over 3 minus 1, which is just 1 over 3, and we're reducing it by 1 because of our shortcut. So the derivative of x to the power of 4 over 3 is just 4 over 3 x to the power of, is x to the power of 1 over 3. Sorry about that. And basically what we do is we take the 12 and we multiply it back into the formula. The k, we multiply it back into the formula to get our derivative of f at x, which is just 16x to the power of 1 over 3. How was that?